Hello, class, and welcome to the last section of Chapter 10 that we'll be talking about. This section we're going to do volume and surface area of spheres. And spheres are pretty popular in our recreational, everyday type things. So all those balls that we're playing with, basketballs, soccer balls, volleyballs, those are all great examples of spheres. So we have two formulas to jot down, and I have a couple of vocabulary words for you. So if you want to push pause and go ahead and get those vocabulary words written down, then we can continue on. Okay, so hopefully you've jotted them down and you've put them in your own words. And remember, if you have any questions or you don't understand something, please write that question to the side and bring it to class with you. And then we can get those questions answered and hope everybody's understanding. So some important parts of a sphere. We all know basically a sphere is just a ball. That's our basic shape that we've seen in our examples. The center of the sphere is going to be really important. And then the radius of the sphere. So just like in the circle when we use the R, we're going to use R for spheres and the radius here also. Hemispheres are kind of cool. Anytime I take that circle and I cut it in half, then we can start talking about hemispheres. And so there's my little, and then a hemisphere is kind of neat because then I do have one base. Now remember when we talked about vertices, bases, edges, and all those things in 10-1, sphere was that special case, if you flip back, that had no faces, no edges, and no vertices. So here's that. But if I cut it in half, and now I have a hemisphere, now I do have one face, and that face is considered to be the base. And if I cut it directly in half, passing through the center, so that I do have a hemisphere, then that base or face is considered the great circle. So all those properties of circles are going to apply to this great circle. And that's actually the largest circle you could slice if you were doing cross sections of a sphere. All right. Also, hopefully you've already tacked this down or taped it down. We're going to talk volume. And our volume formula, it's already written out for you. And surface area. And that surface area, if you can't read it, does say 4 pi r squared. And that little extra, I'm not sure what that's for. So it just says 4 pi r squared. For volume, it is 4/3 pi r cubed. We're going to do a little activity tomorrow and determine why we have a 4/3 and see if you can guess why too on your own. All right, so I am just going to move to my examples, and you should have your little booklet. I have folded it like a pamphlet. You may have one that's kind of recycled, so you see a bunch of handwritten examples on one side and typed examples on the other side. The typed side is what we're going to work with. So I'm going to fold it, portrait, or top to bottom. Then I'm going to fold it like a pamphlet. And maybe we've done this in class, but if we haven't, maybe you missed it, that's how you're going to fold it. So now you're looking at it like this. So I'm going to move to my left-hand side and work some examples with you. So I'm going to do one, then I'm going to leave one for you. All right. So every time we do this, I am going to need my formula. So identify what you're using. Are you using volume or are you using surface area? So this one asked me to find the volume. And since we're dealing with pi and circles, this one does say leave in terms of pi. So I'm going to have an answer with a pi. I'm not going to punch it into the calculator. So volume, we said, was 4/3 pi r cubed. And I'll even show you a trick on the calculator where you can find the cubed. All right, r in this case does happen to be 6, so they gave it to us. So this one should go real fast. 4/3 pi 6 to the 3rd power. Two ways in the calculator I can get 6 to the 3rd power. I can type 6 and the little caret or house key and 3, and that's going to give me 6 to the 3rd power. Or I can type 6 and then I can press the math. We do that fraction, inner. Well, if you look down to the third one, It's cubed, and now I have 6 to the third power. Same answer. So either one that you're comfortable with, you can use math or you can use the caret key. But I'm going to let you finish solving this one out. Leave your answer in terms of pi. All right, the second one says surface area. This time, notice that they don't give us the radius. They give me something else. And that's it. They give me the diameter. So what is my radius? Hopefully you guessed 11. Now I can put it into my formula. Surface area formula is 4 pi r squared. So 4 pi 11 squared. And I'm going to let you finish that one out on your own. All right, open it up. Now we have some real examples, no pictures. Let's see, working backwards. I have a globe with a volume of 288 pi inches cubed. What is the surface area of this globe? So just like when we worked backwards before, find your formula. 4/3 pi r cubed. Plug in what you do know. So I know the volume. And now I'm going to work to solve. Notice that the only variable I now have is my r, so I'm going to be finding my radius. Once I find my radius, I can plug it in for surface area. So this would be a good time if you want to pause and see if you can work it out on your own. All right, so I'm going to go about solving for r. First things I'm going to do is I'm going to cancel out my pi's. So I can divide both sides by pi. These two pi's cancel. These two pi's cancel. And I'm left with something a little bit simpler. So 288 equals 4/3 r cubed. My goal is still to get rid of the, or get the r alone. So however you like to clean this up, that's going to be up to you. But since I know this is 4/3 times r, I can divide by 4/3. And if you can remember your fractions, dividing with fractions, remember the leave, change, flip. So this really means 288 times 3/4. Or in my calculator, I like this calculator, 288 divided by parentheses 4/3. And it'll do it for me. I don't even have to remember leave, change, flip. And I get 216 equals r cubed. All right, if you don't know all your cube roots, in order to get r by itself, I will have to take the cube root. And we'll practice this again in class. So this is something a little bit different, but if you looked at the math key when I did it just a moment ago, there it is, cube root. 216. So my radius should be 6. If you don't have one of these calculators at home or something that can do the cube root for you, then you can go through and test your cubes. And what I mean is say 1 raised to the cube, 2 raised to the third power, 3 raised to the third power, and so forth, and keep going until you run into the answer you want. So it's pretty small. It shouldn't take you too long. Otherwise, there's free calculators online. There's one in my resource page on the website, or if you turn your little iPod sideways, maybe we can find the cube root on there. All right, so we need to go back, make sure you answer the question they asked. They asked you now to find surface area. So 4 pi r squared is going to give me my surface area. And you can get that, just leave your answer in terms of pi. All right, so number 4 says find the radius of a sphere if I'm given the volume. I'm going to leave this one for you. I want you to go back and work it just like number 3, only you don't even have to do the extra step with the surface area. Okay, so working backwards. All right, open it up all the way, and we have one last problem I'm going to help you set up, and then you're going to finish on your own. This one says find the surface area and the volume of the composite figure. Leave your answer in terms of pi and round your answer. So first we need to identify what two shapes are making up this composite figure. And hopefully you've already done that. So we have a hemisphere, and on this side, that's right, we have a cone. So take it into two pieces. If I'm finding surface area, think about how much of this surface is showing. So remember in class I said if I put these together and I dipped them in paint, how much of it's going to be painted. So in this case, I'm only going to need the laterals, so what's going all the way around the cone. I don't need the base. And then on this hemisphere, remember hemisphere is only half. So whatever surface area I find, I get to divide that by 2. So let's start. I'm going to start with the hemisphere on this side. Surface area says 4 pi r squared. And then I'm going to cut it in half because I only need a hemisphere. So 2 pi 6 squared is 36. And then I'm going to add this to my cone surface area. And cone surface area, if you have to look back in your formula chart, go ahead. And remember, we already decided laterals, so that's pi r L, which is my slant height. Sorry, I'm moving. So we got pi r is 6, and slant height, that's so nice that they already gave it to us, is 2 radical 34. Okay, let's see if we can clean it up. 2 times 36, you should have already been putting in your calculator. Plus 6 times 2 is 12. Radical 34 is along for the ride. Pi's on the back side. This is as low as I can go. I can't clean it up anymore if I'm going to leave it in terms of pi. And the reason I can't is because of the radical. I do have 2 pi's. I could add those, but since I have the radical, it kind of stops me. But now I'm ready to get a rounded answer. So 72 pi plus, we said 12 radical 34 pi. And I should have 446 point, I said round to the 10th, so that should be it. Centimeters, and we're finding surface area, so squared. So I'm going to leave you to find volume. Remember, when you're finding volume of the hemisphere, you will have to take it in half, so 4/3 pi r cubed, and I only need half of that. And then the volume of the cube, or cone, I'm sorry, I said cube, but a volume of the cone, which we already said was 1/3 pi r squared times h. You will have to find your h in there, so I'll help you label it. Use your right triangle properties. The L becomes my hypotenuse, and let's see what you can get from there. So be ready to talk about it. All right, so that wraps up Chapter 10. Hopefully you did well on your quiz and you've already started reviewing for the test, and I will see you in class tomorrow. Have a great evening.